All right. Thank you everyone for joining. And this is session 5 in the Oblivious Office Hours that we are doing for the UN Datathon Pet Track. Uh, so today we want to focus on coding a classification model, the tips and techniques you need to use. We will go through 2 notebooks today and a few different techniques of the classification model. This intro is meant to be super beginner friendly. So if at any point you are facing any issues or problems, please just raise your hand in the chat and we will address those issues. This is meant as a code along. I also have Shobit Nair in the participants with me, who is a developer and has worked on developing the algorithms behind the anti-granular private Python package that you have been using in the last few sessions. So I will be constantly plugging into Shobit's expertise throughout the session. Again, this is the full calendar of things. We are obviously coming very close to the beginning of the hackathon. We have only 3 sessions left to go in this series. And then on Friday, obviously, the hackathon will kick off. So please use these forums to ask as many questions as you want, and hopefully we can address most of them as we go along. Again, this Slido link, I think I have shared it a couple of times, but this is where we are asking the questions for the duration of the chat, or for the duration of the session. So if you go there and you post your questions, you'll be able to see what others are asking, and then I can have a look at that towards the end. I'll just post this in the chat again. And then also, as I mentioned before, there is the UN Discord as well as the Oblivious Discord. And there, on the UN Discord, you'll be able to ask questions and get clarification. The Oblivious Discord is obviously anything and everything you want to understand about secure enclaves and anti-granular. And so we are all available on both those forums to help you and support you. Again, the agenda and the purpose, why we are doing what we are doing. We want you all to obviously have a great hackathon experience, and we want to help lay the foundation for you to become an expert data scientist. And we really want you to understand what are the tips, tools, techniques you can use to carry out responsible data science, so that you can find insights from data without compromising the privacy of individuals and institutions. This is very much in line with the spirit of the UN Datathon and in line with what we are doing at Oblivious. So I will give a quick refresher of the concept first, and then we will jump right into the classification model code along. So first, just a reminder on the kind of uh, like knowledge graph or network we saw of how to think of the space of models. I think that thinking in terms of tasks is really, really helpful. Think of the task that you're trying to accomplish on the data set that you have chosen. And there are many ways of cutting tasks, but one that I particularly shared in our previous presentations was you can be doing clustering, classification, regression tasks, and decision-making tasks, and probably these are the ones that are more suited for the datathon. And then based on that, you can see if you want to do supervised or unsupervised learning on your data set, and then you can choose the correct model based on those choices that you have made. And depending on the data set that you have, if it's kind of a streaming data set or like an updating data set, you might want to go for online learning. But I think for the hackathon, batch processing is the way to go for this. Then basically, a quick reminder of what is a classification task. Usually a supervised learning task where we already know and understand the classes that we think exist in the data. We already have a hunch if there are what labels those classes have. And we already know that kind of what are the broad potentially number of those classes as well. This is again different from a clustering challenge, which is an unsupervised learning task. In clustering, you don't necessarily know how many clusters your data set might have, why those clusters might be kind of coming together, what attributes are causing the data to cluster in that way. That is not immediately clear. Like when a clustering task happens, you need to do a few more bits of analysis to arrive at like why the data might have clustered the way it did. So today we are tackling classification tasks, which is like this kind of task like classifying images into categories that you already know your data set has. And today we will take the iris data set and do classification on that. Again, a reminder of the differential privacy image that I want you to keep in mind, that in differential privacy based machine learning, we are working on a data set. We can't quite see the full kind of private information in the data set. The data has been obfuscated in some way, or noise has been added in some way to the data set, but we can still carry out a lot of the insights that we as data scientists want, even if we cannot see the very, very granular private record level information. And this cars analogy that we have used in the last couple of sessions is a useful one to hold for that. So without more ado, like let's jump in to the code along. So if you haven't done already, please go to antigranular.com, and there you can sign in, and that will make it very easy for you to follow along. There, the notebooks that I'm using today are in the notebook section. We'll be using the drug classification notebook, and we will be using the iris classification using random forest notebook as well. So hopefully everybody now understands how to get to these notebooks. And so once the first one we are going to kick off with is this one. So please go to this link. I can share the link as well. So please go there and launch this notebook. So basically making a Google Colab copy, or of course you can make a Jupyter Notebook copy as well, and then just make a local copy to your drive of this notebook. Then in the website itself, please go to the dataset link, and there just copy this information to set up your session. Just click copy here. You'll be able to only do that if you're signed in. Otherwise, it will show you a note. And then you just copy that in your local cell here, where it asks you for session details. And once you have done that, you should be able to access the iris dataset that we are using. I will give a quick pause if people are following along. If there are any issues, just please raise your hand and let me know, and we can quickly debug. Making sense so far? Give me a yay, nay in the chat. Give me a thumbs up, thumbs down. Yeah, would love to know if people are so far. Yes, DSG. Good, or is that a question? Awesome, thumbs up. Perfect, thank you. Okay, then we are going to proceed. I'll keep an eye out on the chat as well. So yeah, first of all, our classic, we'll install the private Python package that is known as antigranular. We'll use our pip install, and that will install the antigranular package. Once this is installed, then we will be able to access all the secure enclave commands, and will be able to interact with the secure enclave. So once we have installed antigranular, we then import the antigranular as AG, and then we set up our session with the credentials that we just put in. Now, this session, when this session is being spun up, what is actually happening in the background is a secure enclave is being allocated for you to engage and interact with, and that secure enclave has the data loaded into it, which is this iris data set as well. And so basically now you have access to two environments. One is the Google Colab normal environment, And then there is the secure enclave environment, which has the privacy built in that we will use. So throughout, you will see that we will kind of use both of these environments. I will call maybe the normal Colab environment sort of our local environment, even though it's not really local to your machine, it's still in the cloud. They are both cloud environments, but sort of just conceptually, there is your home environment or your local environment, and then there is the secure enclave environment, which we will access by doing the percentage AG magic. And this will all become clear as we go along. So no worries if this is not yet clear. Now, so the main thing to remember is that we access the remote or secure enclave environment through this percentage AG magic. So any cell that starts with percentage AG magic is being implemented on the remote secure enclave environment. It is not kind of happening locally. This is something that's happening in the secure enclave environment. So there, we are importing certain libraries. We are importing two types of pandas. And so the first is just your normal pandas, which we are all familiar with. The other is the OP pandas. This is the Oblivious private Python pandas. And we specifically are importing the private data frame functionality from it. And the private data frame is the sort of, conceptually, it's the private analog of your normal pandas data frame. And we are importing some other anti-granular utilities from there. Specifically, we want the export functionality from which we will export between these two environments, the remote one and our local one. And then also the load data set functionality, which is, I think, fairly self-explanatory. Then, so we do that. And again, this cell is being implemented in the secure environment. And again, now in the next cell, we are going to load the data set. So we have the data set ready in the secure enclave. Now we load it, and we will do train X, train Y, and test X, test Y kind of portions of that data set. Again, now this is a really interesting one. I think I'll spend just a bit more time on this cell. So this cell is going to implement on the remote environment, the secure Nitro enclave environment, because it has the percentage AG. And we're using the export function to export train X described, like this will describe the train X with a certain value of epsilon. And epsilon is, as we have talked about in the previous one, epsilon is a measure of the noise you want to add to the data set. And epsilon balances between noise and the kind of usage or utility that you can get out of the data set. The more epsilon you use, the less privacy you will have. The less epsilon you use, the more privacy you have. It's an inverse relationship. And we are exporting that result as result. And we are exporting that into our local environment, the home environment, the normal Google Colab environment. So now we do that, and it basically will export that. It obviously gives you that now this variable has been exported. And now you see this cell, I don't have percentage AG, which means that this is now in my local environment. And here, this is the normal kind of frame. And so this is what this frame looks like, right? It is a describe data frame, and we are used to kind of the describe function, hopefully. So it just gives you like the main high level information. Obviously, it has not given us any count because that keeps the data frame private. There is all the other information that we expect from a describe function. We have received that. And then basically, what we are going to start doing is we are going to start actually interacting with the data set that is in our remote secure environment. Now, why did we do this describe? Is just because conceptually, we are just getting started with the data analysis here, and we are just trying to understand what even is this data set that just we have. then we start getting an understanding of the basic statistics of it. What are the means? What are the various bounds? And this is just the initial exploratory phase that you have just done by doing that describe. Now, we so Shobit here, like I'll start talking to you, and we can make it a bit more conversational. So, what are we trying to achieve with this cell here? Why do we want to do this apply map functionality?
So generally, what we need is that in scenarios, string manipulation or applying differentially private methods on string is not something that we can do at this point. There is nothing like applying some noise on a string. It's not logical. So
Right,
what
right.
generally we need to do is, like, if you need to find, like, apply conditions, or let's say I want to find out how many iris setosa flowers are there later, or maybe I need to filter the data. So I generally would prefer a form in which I can encode the values, and most models that we will see later only accept numerical values.
Right. So basically, this is what, so here we are basically converting string values into some kind of numerical values, correct? I think you might be on mute, Shobit.
Yep. Yeah,
Awesome.
accidentally clicked. Yeah.
Great. So basically, we have converted from our kind of string values into this 0, 1, 2, and we have encoded the train y. Now, in from this train y, we are joining this data set to the previous train x that we already had. So we loaded the train x data set here. We have augmented that data set now with our new encoded augmentation that we have done. We have done a left join here, and we are going to now again get the result, and we will see how it might be different than the result we had just gotten here. So once we import again, our result should change. So you can see that actually you might have just seen that this count was 130 and now it's 128, which means some kind of, privacy preserving noise is being applied. So you get slightly different results when you query that again and again. And so we have received these new values again. And this time, the thing that was all zeros here now has converted into values. And we can see a little bit of an update because now the data that was previously just strings is now accessible to us. So now we do more data exploration. So now we are getting a bit of a handle. Yeah, yes, Raj, that is right. So we are just encoding it, correct?
And I think another
Yeah.
thing that we can see is that in the second query, we actually use more epsilon, which is
Hmm.
one reason why the count was actually closer to the actual result.
Hmm.
And in the previous query, we used very less epsilon of something like 0.1, which
Yeah.
kind of is that utility kind of measure that we do here.
Yeah. Um, should we send more epsilon?
Yeah, I think we
Yeah.
can use more epsilon because Irish dataset is a smaller dataset.
Hmm.
So the dataset size also depends on the amount of epsilon you need to use. So
Yeah.
it's easier to hide one record in a large dataset compared to hiding one record in a small dataset. So that's how
Okay.
you can think about it.
So should I go with 1.5, or do you think like something even bigger?
I think 1.5 would be good. Like, we can
Okay.
compare it with the, like, previous described method and see if it's coming closer.
Yeah, actually, I'm gonna maybe leave this result here, and I'm just going to do a new result in a new cell here. So that one stays there. Okay. Yeah. So yeah, I mean, it's hard for me to tell like how I'm doing, but I'm definitely getting a few different numbers. But like, it's obviously hard for me to say like, am I now doing more accurate or not? And I guess that's probably the challenge here. So I'll just mark it with that 1.5. Yeah, and this one was the result with 0.5 epsilon. Okay, let's keep going. So now we are going to actually import another library called the Noise SQL, and this is the Oblivious private Python version of that library. So it's not Noise SQL is a broad library which allows you to do differentially private queries, and this is kind of a wrapper which works nicely with RTQ enclave. Yes, Raj, go ahead.
Sorry, I just wanted to stop you before you went to the next section. I just had a quick
Sure.
question about the epsilon. So
Mm-hmm.
I'm a little confused with the increased epsilon because based on what I have read so far, it seemed like increasing epsilon essentially you're exposing the data more, right? And
That's right.
reducing. So when Shobit said that a smaller data set, you should use more epsilon versus a larger data set. I'm kind of confused like how this is correlating with the epsilon.
So apparently epsilon by theory is like the probability of finding a record.
Okay.
So if in a smaller data set, it's if you are applying some mechanism, let's say sum or mean or some aggregate,
Okay.
it's tougher to hide that record. Let's say if there are only three records, it would be I think I can theoretically it will be difficult to hide one guy for the
Right.
same epsilon in a data set with 1 lakh people,
Right.
if you measure of it. So that's why I said for the same amount of epsilon, for the same mechanism, two
Yeah.
data set sizes actually give different accuracies.
I see.
Wait, but I think Shobit, what Raj is also saying, right, is that so with a smaller data set, should we be using less epsilon or more epsilon
To get the
to,
same accuracy, you should use more epsilon. It's
Okay.
like
right?
a measure of accuracy here.
I see. I'm just confused in terms of the privacy because I mean, if it is a smaller data set and if you're using a large epsilon, would it be more easily caught, like in terms of privacy is compromised?
Yeah. So actually, let's clarify the term quickly, right? So because we are talking utility is the accuracy and privacy is obviously the preservation of any individual record. So if our goal is obviously more privacy, then with a smaller data set, we will need to use less epsilon to reach the same privacy
I
than
see.
a larger data set. With a larger data set, we can achieve a similar level of privacy by having a bit more epsilon, right?
Right.
Shobit, if I'm not mistaken, like I'm explaining it
Yeah, so
correctly.
you can consider it in this way. For a smaller data set, if we are setting up a privacy budget, we will
Right.
say we'll set up a higher privacy budget because we know that the accuracy he can get, like to get the same accuracy, he would need to spend more epsilon compared to a large data set. So
I
we kind of keep a privacy budget that can be used. So
I see.
depending on the data set sizes, we also
Accuracy or privacy, it will reverse depending on
yeah.
yeah.
Right. So it's essentially a trade-off. Like you have to kind of decide on this trade-off based on the size of the data set.
Yep.
That's right. Yeah.
Okay. Awesome. Thank you so much.
So then we go to this next step where basically we want to do now a bit more exploration of the data set, and we will see a few ways in which we can do that. So now we are setting in Smart Noise SQL, we are setting a privacy budget here, and then we are going to start looking at uh, the kind of data frame we made, which was the one hot encoded data set with the new privacy budget here. Sorry, Martin, do you want to unmute yourself and ask the question? Maybe I didn't get it from the chat.
Yeah, hi Ali. This is Mateen
Hi,
Ahmad.
hi, Martin.
Actually, I want to know this. What is the since you use privacy, right? Here,
Mm-hmm.
um, I didn't get that one. What the work is here? Using privacy, what we are doing here?
Yeah.
Do you
So
mean in the
go ahead.
block 52?
No, I think generally, Mateen, are you asking like generally or specifically to some code stuff?
As per code, like.
Hmm. Yeah, so basically, what we are trying to do here with the code is that
Yeah.
in the Datathon, you will receive a data set which is non-public. So that data set, the same way this data set in this code book is the iris data set, you will receive a specific data set during the Datathon, which is non-public. Nobody has seen that data, and that will be in the secure enclave. You will be doing some kind of queries with that data set to understand, okay, maybe what kind of classes exist in the data set, or can we predict something out of the data set? And to do that, you will be able to ask some questions of the data set without actually being able to print the data set or see the full row by row entries in the data set. And that's the big difference
Okay.
when we are doing responsible data science, is we can't actually, you know, use things like head, or like print the first 100 rows. So you can't do that. So that's why we have to use a slightly different approach to querying the data set by using summary statistics. And that's what we are doing here, is that we haven't seen so far the row by row of how the data set looks. Rather, we are saying, what is the mean of the data set? What is the min max values? What is the kind of sort of probability distribution a little bit of the data set by having this 25%, 50%, 75% ranges. So we are accessing those summary statistics, and that's the privacy angle of this, that without seeing the data set, we want to understand what kind of data set are we dealing with, and so what can we do with it. And so that's what we are doing so far, is just how do I ask questions of the data set to get a handle of it without using traditional methods like making a quick chart or making a histogram immediately. Yeah, does
Right.
that make sense?
That right.
Cool.
Yeah.
Awesome. So then going ahead, what we are going to do is we are going to start looking at, okay, what kind of classes do we have or categories do we have in the data set, and what are the differentially private counts of those categories. So what we want to do is, as you remember, we did the one hot encoding of the data set, and we are now going to use that same logic to identify what is the kind of amount of those categories in the data set. So if you guys remember, like the iris data set is a very standard machine learning or data science toy data set, and it has obviously flowers in it, and we are trying to figure out how can we classify these flowers based on their attributes. And the attributes we have already seen are available to us here in the describe functionality. We have sepal length, like the green part of the flower, the petal length, the colorful part, the petal width, and from that we are trying to understand which species a certain flower may belong to if we get new information or a new data point in the data set. So that's where we are in this section, is we now want to start looking at, in our training data set, what kind of size of each type of flower category do we have. And so is it Google? Yeah, Raj, I'll share so this Google Colab is basically, if you go onto the anti-granular website, and there you go to notebooks, and this notebook is the iris classification using random forest. And when you go there, you just say launch notebook, and it will give you this option to open it in whatever your favorite thing is. And I recommend opening Google Colab, and then that's what I'm working with. You will need to get your key. If you get stuck on that, Raj, you tell me and I'll just show you. To get the key, you just have to click on this part, dataset, notebook, click on this data. Here you have your session ID, copy that and put that in cell number 2 at the very start, where you have the session ID being asked. and then you will be able to run the whole notebook. All right, so coming back to this, so the one-hot encoding that we did, we are going to utilize that to understand and bucket our test data set basically into these categories. And we have obviously got a, Shobit, am I mistaken? Total cost is basically like we are trying to understand how much epsilon and delta we have spent, right?
Yeah, so basically how this is that, for example, in the code block 52, we are
Yeah.
kind of defining for one unit operation how much epsilon should be used. Like you're defining a privacy parameter. So this works a bit different to how OP Pandas works. In OP Pandas, we say that we only want epsilon 1 to be used and it gets distributed internally.
Right.
But in SmartNAS SQL, you say each unit operation should take epsilon 1. So you need to kind of estimate the total cost before you execute the query. So in the next line, we are estimating the cost that would be incurred for this query.
Yeah, perfect. So basically, this is a budgeting phase in a way, or for you to run this query. We haven't run this query yet. This is just the budgeting phase to understand if you can even afford to run this query. Because obviously you don't want to run something and then you realize, oh shit, I ran out of the privacy budget. And so first, these three lines, and yeah, it basically tells you it will cost you 6 epsilon. And so basically, yeah, now we go ahead and we actually execute the thing that we tested. And you can see, obviously, this is exactly what we had up there. So now we basically, when we run this query, it is bucketing the varieties or of the flowers using the one-hot encoding that we did in the section above. And then now we are going to try and visualize this. So you can see that the last line here was exporting. So I've exported those counts into the local environment as counts. And now we will be able to work with that and make diagrams out of that. And so first, I understand that, okay, I've gotten almost like 40 of each. So it's a fairly equally distributed data set. And I want to just visualize that. So I use Seaborn, Matplotlib. You can use whatever your favorite visualizer is. And this is all happening now in your local environment. This is not happening in the secure enclave. So this is just in your local environment. You're visualizing the categories. So these are the ones we have identified. Now, we want to start understanding some more advanced techniques on like understanding the data set, understanding how we might classify certain things. And for that, we are, so Shobit, please talk me through a little bit, like what do we achieve in this section? Because there is obviously the secure enclave part we have done, and then we do some local environment magic.
So in this part, we are just trying to find out, like before we pass them through the model, we just want to see which parameters actually depend each other. So we're trying to just get the correlation of each features of that flowers category. So that's what we're trying to achieve before classifying it.
Yeah, perfect. Awesome. So this, guys, if you remember from our previous session, this falls here in our pipeline where we can start understanding what kind of features we may be able to build from the data set. So by understanding the relationships that exist in the different columns of the data set, we can start thinking around, okay, the correlations in the data set are between these two values. So maybe I can create a new feature around them, or I can combine two things which may be not so correlated. Maybe that creates a different type of feature which has some importance. And so this step, again, like you can feed into your pipeline to make new features that make you that allow you to do better classification, better prediction, etc. So of course this is a kind of just a flower data set, but if you imagine that you will get some data about an urban environment, maybe you want to understand is people's salary correlated with the price of the house that they are renting or something like that. If you get the data like a geospatial data set, so this would be the place where you will by doing correlations, you can start uncovering those relationships, that if the salary is correlated with the house rent price or the value of the price or the postcode number, this is where ideally those correlations will start showing up, and you can really start seeing what might be important for your data set versus what is not. I don't think I implemented this cell. So again, this is something now you have exported from the remote. So there you ran the correlation with epsilon 7, and you imported it into your local environment. Shobit, quick question. How did we decide this should be epsilon 7?
So mainly, if you think about applying epsilon, earlier we were just applying on simple operations like sum, mean, max, which are considered as the unit operations. But
Mhm.
correlation is a complex function which applies to each and every cell like a Cartesian product. So you generally have to spend like at least n times m of the epsilon that you spent before, roughly. So earlier we were spending like 0.5, now we are spending like something like 16 into 0.5, roughly.
Yeah.
Like
Perfect.
a fair estimate.
Amazing. Okay. So this then we exported that result. We are looking at that heat map to understand those correlations that exist. And now I think comes the interesting part, probably what it says on the tin is we finally do some machine learning or some data science. And to do that, we actually have the diffrib library that we are going to use. And we have again, the Oblivious private Python version of the diffrib library. And from that library, we are going to use the random forest classifier. And just while kind of we are on this point, there are many other models that you can use. Raj, I'll come back to you in just 1 second. So there are many models you can use. So actually, in the other example that I will briefly show is we are going to use some other models as well. And we are going to look at beyond just the kind of random forest classifier, we will also look at the logistic regression model, the Gaussian noise model, and basically we can try out the multiple models to see which one is the best fit for us. Please go ahead, Raj. Yes.
So I have a question again about this correlation. You added the epsilon to it, and you just explained the decision behind it. So I'm wondering, like, for instance, as I start my project and I start using epsilons, and then I decide, well, I feel like I'm going over budget. So then I decide, can I just scrap the whole thing and start afresh? And will that still count as my epsilon usage, or?
Yes, it will count as an epsilon usage because anyone can just do it, save the results onto a file and then just reset, right? Because that would not be a fair practice to do. So ideally, what I would suggest is to start smaller. So
Okay.
then you have like a much better margin of error.
Okay.
If you, yeah.
Yeah, and to basically use an analogy, right? Like because the data set is obviously like it's some kind of information that needs privacy. And the main hypothesis or the fundamental hypothesis in differential privacy is that if you ask enough questions of a data set, you will be able to reconstruct the data set. And
Right.
so the thing that we are doing is we limit the questions you can ask, and then we give you noisy answers to the response. Because unfortunately, like even if you said, let me start again, we can't really, wipe your drive, or we can't wipe your memory to make you forget what information you already found out about the data set. But I think what potentially helps is we'll see if we maybe upload a similar sandbox data set so you can kind of practice a little bit on the sandbox first, and then you can check the main data itself so that you can do the kind of early learning phase stuff on the sandbox, but then you try the real stuff on the main data set without losing your epsilon.
Oh, okay. I had
Yeah.
a follow-up question. Sorry. So
Yeah,
I
yeah.
was just wondering, So there is supposed to be this data sets that will be open to us once the challenge starts. But I'm curious, like, if people are already all looking into like what kind of projects they want to do in this competition, and we don't have any idea what data sets there are versus UN already has shown all the data sets they have. So how would we able to know the data sets that we choose will be, aligned with the data sets that we'll find on here? So
Yeah.
yes,
So
I'm kind of confused, like how this is gonna correlate.
yeah, so basically the way it will work is that the data set you're going to get for the PETS track is the unpublished latest results of a kind of data set that has been published in the past years. So like you will be able to, and this will go up on the wiki shortly, so hopefully people will get a prompt about that as well. But basically like there will be data set from 2020, 2021, etc. that you can use to practice. But then maybe the 2023 data set is the one that hasn't been published yet, which will be published in a couple of months. So it is not yet publicly available. So you will be able to then practice on the past years, but then the one now you will be private. Maybe I've misunderstood your question.
I'm trying to understand, like, there are so many different data sets that's already available on UN dataset section. So because here there will be a new sort of data sets that will be given to us at the start of this competition or hackathon. So I'm just kind of curious because many people can choose different. There is so many different projects that you can do out of all these data sets. So
Yeah.
I'm wondering how will we know that whatever we choose, and because I am sure a lot of people are already thinking about the projects they would want to do. I'm just unsure how, doing the pet challenge will align with those projects that we decide to work on.
Yeah. So I mean the important thing obviously like is that the PETS track you need to be using privacy preserving technologies, and ideally you work on the private data set that also is being shared with you. So now what will also go up is the data spec sheet on the wiki, and it will go up, I think, either end of today or tomorrow. So you'll be able to see the full spec sheet of like what is coming in the data set, what information it has, how it was collected. So you will be able to use all that information in your decision making to think through, okay, I can maybe combine this private data set with some other things that are more publicly available. And if I kind of do the joint data science on these, then I think it gives an interesting problem. So maybe that data spec sheet will help you make that decision and understand exactly what is in that private data set.
Okay, awesome. Okay, thank you.
Awesome. Just being mindful that like I know that we are coming almost to the end of our time. So I'll just quickly run through like, I mean, the meaty part is here, which is the machine learning of it all is just starting. So first, we get our random forest classifier, which I think is one of the early classifier you should be using in most classification problems. You should apply it and see how your model does on that. And here then we have used our TrainX that we previously got into our secure enclave. Here we got this TrainX loaded into the secure enclave, and now we are basically running our random forest classifier on that TrainX. Once we have that, it is all in the secure enclave. Nothing has been exported to us yet. Now we fit the TrainX train-y data, and again, this all is still happening in the secure enclave. And then once the fitting is done, we do the prediction step. And that prediction step's result, we export into our local environment. And then we will start seeing kind of like what output it has given us. So as Shobit mentioned, it is a fairly small data set. So obviously the prediction the prediction array is not that large, but in some instances, like you can get thousands of prediction values if that's if that's how the data set is set up. Now, actually, how the UN one is set up, you can decide on what you need to be your training versus the prediction value. Maybe you want to predict something for like just a month of data you want to predict on. You want to say like, actually, if you train your model on all these like 12 or 13 months of data, we can then predict what the next forecast is going to be, or these are the most valuable predictive factors for predicting this forecast. And that then really becomes a decision type of question. You can say like income, or like if you have a TV or not, or what is the color of your roof. Like all these things will predict if this family in the next year is going to, move out, or if their salary is going to increase, something like that. Like that's just an example of like the kind of things you could start doing by predicting the classes of a given data set. And now, like once we have done that training, we want to just basically, again, keep a track of where we are doing in our privacy budget. And that this is kind of what, for example, was just asked, like we don't want to go over budget, and this is how you keep track of your budget. So in terms of the model performance, this, because this will need to be like submitted, the result, and from that you can see like what is your accuracy and what is your leaderboard score. So that's where this comes out. And I don't think we have a leaderboard set up right now, so it's hard to do this on this data set. Or Shobit, maybe I've missed something. Like, is there a way to understand how well we have done on this?
I don't think it's set up for this data sets at this
Yeah.
point.
Yeah. So hyperparameter search is possible. How would we do? I mean, the hyperparameter search does not need to happen on the test data set, right? Like you preserve the you carry out the hyperparameter search on the training data set, because if you start taking into consideration your test data set, then you're overfitting to your data. So the hyperparameter search happens in the earlier part, and it happens on your training data set only, not your testing data set. Yeah.
Right. Sorry, I think maybe I didn't explain it well. I was trying to say like you fit that, and like how do we know this model that you fit on this test
Right.
set is performing well before we start doing the prediction? Like, isn't there some sort of, R-squared score checking or, MAE scores, like, and so on? Like, how is that not possible? Or because how else would we know that
Yeah.
this hyperparameter we have chosen is the right one?
Yeah. Shobit, which ones have we enabled in the OP version of diffriblib? Any idea? Like,
I think currently we have the binary accuracy and MAC, right? That's what we have set up for now. And I think a modified version of MAC was also used in the previous Harvard contest.
okay. I think, Raj, what I'll do is I'll look up separately, like where in the documentation we have that covered. And I think I'll cover that in tomorrow's session as well, like just to
Awesome.
see like how we can properly do a check of fit performance.
Awesome. Thank you.
But then just to maybe give a brief flavor of because I think what you guys can do is, because I've taken you through this one notebook, I think as a sort of homework, if you will, if you want and go running through this second notebook, which is on the drug classification data set, it gives a better flavor of other types of classification algorithms that you can use. It's a different type of data set. It has way more kind of categories, but also it is a very small data set. So you will very quickly see how you run into epsilon issues. So it's also a good kind of toy problem to get a bit better feel about epsilon challenges. None of the data sets in the Datathon will be this small. but this just will help build your intuition around epsilon and similar. Like you can just run through this notebook and see for yourself, like if you're running into any issues or whatnot. I'll pause there, and then we will do regression tomorrow. And in that, again, we will get a better handle of how to basically do, machine learning when you cannot look at the data. And hopefully tomorrow we will also have the data sheet up for the pets track. So everybody will we can discuss that tomorrow as well, that like what kind of data you will be expecting to come, what would be the historical data set you can see already, which is already public, and you can start building an intuition around that. So yeah, I'll pause there. If there are any questions, I'm happy to take them now. Cool, awesome. I think we then wrap it up there, guys. Really appreciate everyone joining, and I hope this session was useful. And hopefully I'll see you guys tomorrow.
Ali, just a small question. Do you hear me?
Sure. Yes, I do, Ada.
Thanks a lot. I wanted to ask, will this recording also be available on the page of DU in Datathon?
Yes, it will be. It will be.
Okay. Thanks a lot. Have a great day.
Awesome.
Thank you. Take
Awesome.
care. Bye.
Take care, everyone. Bye-bye.
Have a nice day, everyone. Bye.